Assalamu alaikum wa rahmatullahi wa barakatuh, and welcome to another explosive, action-packed episode of the K-Way Mathematics program here on ITV. I'm your host, Mohammed Kota from the K-Way Mathematics Institute here in Johannesburg, and I'll be presenting to you better ways, shortcuts, and dynamic techniques in order for you, the grade 11 or 12 learner, in order to pass your exams for 2015 here in South Africa. Right, let's get started. We ended up on our last calculus show, we ended up with the cubic function. I did promise you, yes, our last topic is optimization with volume and total surface area, but I did promise you that I'm going to explain to you what is the point of inflection. So let's go into the point of inflection a little bit before we actually get into optimization. So the point of inflection, generally the question will just ask, give the x point of the point of inflection. Now point of inflection, just to show you what the process is, point of inflection, this is the actual point on the graph, and generally they will just ask you for the x point or the x coordinate of the point of inflection of the graph. Okay, now point of inflection, guys, you all know, your teachers probably told you this already, this is the only time in calculus where you will be using second derivative. Other than that, you will continue using first derivative. The only time you will use second derivative is when you are trying to find out the x value of the point of inflection. The derivative of the derivative, that is called second derivative or the point of inflection. So if your original graph was f of x was equal to, in our previous episode the example that we used was x cubed plus x squared minus 5x plus 3. We then found the first derivative, which was 3x squared plus 2x minus 5. If you still have your notes, right, go back to those notes and check. And now for the point of inflection, POI, point of inflection, the x value, we're now going to say f double dash x, second derivative, is equal to 3 times 2, 6x plus 2. We equate it to 0. Solve for x. 6x is equal to minus 2. X is equal to minus 2 over 6. X is equal to minus a third. Boys and girls, that is how you would find the x value of your point of inflection. Now, let me explain to you. Your teachers might have explained to you this concept already. What is the point of inflection? That is the actual point on the graph where the graph changes its direction from increasing to decreasing, from concave down to concave up, or concave up to concave down. That is it. Minus a third. Now, when you sketch a graph, I just wanted to show you, because sometimes to many of you this is not making sense at all. So you see a graph. If you remember what this graph looked like in our previous episode, the graph looked like that. The point of inflection would probably be somewhere there, minus a third and there. That's the point of inflection. Now you might ask, now what relevance does that point have on the graph? Why is that point the exact point in which the graph turns? Okay, let me explain to you something. We do know that 3x squared plus 2x minus 5, first derivative, is a parabola. The first derivative is a parabola. Now if you had to sketch this from your knowledge of functions, if you had to sketch the derivative, what would the derivative look like? The derivative would look something like, I'm just doing a rough sketch, would look like that. There we go, that is your derivative. So this is now not f of x, because f of x was your cubic, so this is f dash x. F dash x, you can sketch your derivative. So sometimes in the exam they will tell you, sketched is the derivative of the original. Find the derivative. I'll show you how to do that. But coming back to the point of inflection. So if this was the derivative, the graph is the derivative, and the x value is the turning point of your derivative. So there we go. That is the point. Okay, but obviously this graph is not drawn to scale. X is equal to minus a third. So basically this graph would probably look, just to show you, to draw it a little more accurately than that, the graph would probably go like that. That's your x value of minus a third. Now that point there, that point is your point of inflection. Point of inflection. That is your point of inflection. It shows you exactly that the graph here is changing from decreasing to increasing. That is your point of inflection, this minus a third, because this is your derivative of your derivative. So f dash x was your original, and this point here is your f double dash x. So the point of inflection after sketching the graph will represent the derivative of the derivative, or the turning point of that parabola. Now, question that appeared in about two years ago in the final exam, right? And this knocked most of the grade 12s out. They gave you the derivative. They gave you the derivative as a graph. So all they did, I think this was November 2011 or November 2012. They gave you a graph like this. They told you that this point here was 2 and that was negative 1. And they told you that this was f dash x. And they told you that the question in the exam stated, it said sketched, there's it, sketched is the derivative of f of x, of the original. Find the derivative. Question, answer. Now boys and girls, this is not a calculus question. This is a functions question. Why? This is a parabola. They tell you, they just sketched the derivative. They want the equation of the derivative. How do we get it? So it's absolutely easy. All we have to do is we say f dash x is equal to, we given two x-intercepts, x minus x1, x minus x2. This is equal to x plus 1 into x minus 2, which is equal to x squared plus 1 minus 2 minus x minus 2. There we go. That is your derivative. The derivative is the equation. This equation here is this equation is the equation of your derivative. Okay? That's it.